Okay, we're continuing with the intro to functions. So we're going to talk about domain and range. Well, the domain is all possible x values. The range is all possible y values. So if you remember from the last little section, a relation is a set of points, right? So in the last little section, we looked at a set of points that looked like this. This is a set of points. There was 3 here, right? Look at this XY graph. Well, this is also a set of points, right? How many points are here? This one had 3. How many points? Infinite, right? But it's still a relation. Is this one a function? We'll get to that. Let's see. This is a set of points. Can you believe it? Let's see. What if we made a t-chart to go with this and we plugged in 0? What would come out? 1. If we plugged in 1, what would come out? 2 times 1 is 2, plus 3 is 5. So this is a set of points too. How many points does this one have? Infinite. Infinite, right? So we have a set of points, set of points, set of points, and this is a set of points too. And you can get all these points for this one too just by plugging in an x and seeing what y comes out. So let's look at the domain and range for all of these, and let's determine if they're functions. Okay, well, let's look at this first one. All possible x values, all possible x values. I'm gonna list out the domain. Since there's only 3 points, there's 3 x values for this domain. So we have let's see, the domain would be these little squigglies, these little squiggly brackets. That lets you know that you're talking about a set of numbers. So the domain for this one would be 2, 4, and 10. Okay, and the range is all possible y values, all possible y values. Okay, so the range would be, let's say it's 3, 3, 5, and 20. That's pretty easy, right? Listing all the x values, all the x values and the y values. Nobody saw this, but I'm changing that just a little bit. Okay, the domain for this one, all possible x values. How far to the left does this line go? That would be its smallest x value. Well, it goes to the left forever, right? It goes to the left forever. So the domain would be negative infinity. And how far to the right does it go? How far? Well, forever, right? So the domain would be negative infinity to infinity. Have you seen this before? This is interval notation. I'm sure you've seen it in your Algebra 3-4 or Honors Algebra 3-4 class, but this means that the smallest x could be would be to negative infinity. And the biggest x could be would be infinity. How far down does it go? What's the smallest y value that you see? Anybody? Yeah. Negative infinity goes all the way down to negative infinity. And how far up does it go? All the way up to infinity. So the domain, all possible x values for this one would be negative infinity to infinity, and the range, because it goes down forever, would be negative infinity to infinity. Look at this one. If I was to graph this, what shape would it make? It would make a line. A line goes left infinitely, right infinitely. Most lines, except for unless it's horizontal, a line goes down infinitely and up infinitely. Also, you can look at it from the equations perspective. What's the smallest number you could replace x with? You can put any number you want in. You can multiply. There's no restrictions when it comes to multiplying a number by 2. So theoretically, I could put negative infinity. Theoretically, I could put positive infinity. This line, this is a line, it's just in an equation form, and it's still a set of points, right? So it's a function, and the domain for this one is negative infinity to infinity, and the range goes down forever, up forever. The range is negative infinity to infinity also. Now this one's a little different. This one's a square root, because a square root has restrictions. What kind of number are you never allowed to take a square root of? A negative. Can you take the square root of 0? What is it? What's the square root of 0? 0. Good. But you can't take a square root of negative. So this is kind of tricky, and maybe like a little advanced for this point of the class, but I'm going to introduce it now with some explanation, and if you get confused, please ask me questions. So, if x plus 1 can be 0, but it can't be less than 0, then we would say x plus 1 must be greater than or equal to 0, okay? What that means is, if you subtract 1 from each side, x could be anything as long as it's greater than or equal to -1, all right? X can be anything as long as it's greater than or equal to -1. So could x be -1? Yeah. Could it be 0? 0 plus 1 is 1. The square root of 1 is something we can do. Yeah. Anything greater than or equal to -1. So that's one way of listing the domain. The domain is x is greater than or equal to -1. Another way to write that, you might remember this interval notation. Well, we say -1 all the way up to infinity. Now, this isn't a lesson about interval notation. You can tell me the domain however you want. I don't really have time in this video to talk about interval notation. If you want to know more about interval notation, I'd be happy to teach you. But x must be greater than or equal to -1. This is saying the same thing. X can be -1 all the way to infinity. How about range? Range. All right. So what's the smallest number we can plug in? -1, right? If we plug in -1, we see the smallest possible y value. -1 plus 1 is 0. The square root of 0 is 0. So the smallest y value or output that you could get would be y must be greater than or equal to 0. Or if you wanted to do that interval notation, you would do a bracket 0, comma to infinity. Now, another way you can find domain and range from here is by graphing this in your calculator. If you graph this, we're going to learn how to graph these by hand a little later on. You can always use a T-chart to graph by hand. But if you were to graph this one in a calculator, it would look like this. It would have an endpoint right here that's one space to the left and on the x-axis, and it would go up and forever to the right. Look at this graph. It goes all the way to -1, but not past it, making our domain from -1 to infinity, or the domain x has to be greater than or equal to -1. And the lowest y value, if you graph in your calculator, it goes down to 0, but not down further than that. So the y values can be everything from 0 all the way up to infinity. All right, what do you think? Okay, now, there's one more thing I want to talk about in determining functions. I'm going to erase all this real quickly. And then I'll put something up here. It's another way, so we're focusing on domain and range in this video, but in the first video we were determining if something was a function. So this is called the vertical line test. Okay, probably sounds familiar. And it's this: if a vertical line touches a relation, which is a set of points, more than once, it is not a function. So this test, it works when you have graphs of a relation. You want to determine if it's a function. So let's try it out. I'm just going to put a few examples up. Okay. So, look at this first relation or set of points here. We want to determine if it's a function. Is there any vertical line that could touch it twice? No, there's not. Therefore, this passes the vertical line test. And this one is, yes, it is a function. Okay, I want to point something out though. If you tell me, if I ask you on the test and I say, why is this a function? And you say, because it passes the vertical line test, that's not the reason why, and I won't like that answer. The reason why is always the same. The reason a relation of function never has a different answer. It's always the same, and the reason is each x value produces only one y value, okay? Look at this one. Does this pass the vertical line test? We have an x value, or look at this vertical line right here. No, it does not pass the vertical line test. We have that vertical line touching here and here. And if it touches more than once anywhere, it's not a function. But the real reason is because we have an x value or input or a domain value that's producing more than one y value. You have to know what you're getting out when you put something in, otherwise it's not functionable and it's not a function. Let's say this x value is 1. Let me add some y marks here. And so this point would be 1, 4, and this point would be 1, -5. And the reason that this can't be a function is if I put in 1, an x value of 1, I got out a 4, that's not the same as I got down here. And the easy way to tell that from a graph that the relation is going to do that, making it not a function, is by applying the vertical line test, right? So, does this one here pass the vertical line test, this sideways parabola looking thing? It doesn't. Is it a function? No. What's the reason that it's not a function? And don't tell me because it passes the vertical line test, it gets me real fired up. The reason it's not a function is because you have x values in this relation that have more than one y value that come out of that. Like if I did an x value of 3, and I have a point here and here, and say this point is 3, 5, and this point is 3, -3, I don't know what I'm getting out if I put in a 3, if I input a 3. So that would not be a function. Okay, real quickly, just for the sake of fun, what's the domain? The domain of this one goes from -infinity to +infinity. It goes down forever and up forever. So the range is -infinity to +infinity. How about this one? Let me add some marks. Let's say this point here is -5, and this point here is, so that's -5, 0, and this point here is 1, 2, 3, 4, 0. Well, what's the domain? How far left does it go? -5? How far right does it go? 4? So the domain would be -5 to 4. What's the range? Looks like it goes all the way down to -5 and all the way up to 4. Oh, it's also -5 to 4. I want to point something out. Sometimes I've had kids tell me, well, it's not a function, you can't find the domain and range. Well, that's not true. You can still find the domain and range even if it's not a function. You can still find all possible x values and all possible y values. All right, and this one here. Let's see, the domain, let's say it goes to the left -2, so the domain would be from -2 to infinity, and the range would be, how far down does it go? Well, if you look at it, it's going to go down forever. It's going to go up forever. So the range for this one would be -infinity to infinity. All right, thank you so much for this 3.5 lessons. Up next, we got our test, and the test is going to include 3.1, 3.2, 3.3, and 3.5. I'm excited.